Hello and welcome to a video by www.electricalpereview.com. In this episode, we're going to be doing an example of autotransformers from single-phase transformers. So say you work at a facility and you've got a slightly high voltage of 4640 and you've got an equipment rated voltage for 4160, and all you have laying around is a 480 volt to 4160 volt transformer. That's 75 kVA rated. Could you use this single-phase transformer to make a step-down autotransformer in order to regulate your voltage to where it needs to be to match the equipment rating of 4160? The answer, of course, is yes. First thing we do is we draw our single-phase transformer. Here's our primary winding. Here's our secondary winding. So this could be either a step-up or step-down, depending on which way you look at it, but we're going to draw it in the way it's given to us as a step-up. So 480 volt input, 4160 volt output, and our N1 to N2. If we divide 4160 by 480, that gives us an equivalent 1 to 8.67. Now, the most important thing we're being asked is find the volt amp rating of this new autotransformer given the information here. So the first thing we need to figure out is which winding do we need to stack on top in order to regulate 4640 volts down to 4160 volts. Well, if we subtract 4160 from 4640, we end up with 480. So that tells us that we need to stack our primary winding on top of our secondary winding. Let's see if the math checks out. So if this is our new connection here, primary winding on top of our secondary winding, here's our common line, here's our new tap for our step down. If this is our input, if we take our 4160 winding on the secondary plus our 480 volt on our primary, we do the math and that gives us 4640 volts. Since we're stepping down to 4160 on the primary, we know we want to keep this coil as the bottom coil. So this is going to be our output. Plus 4160 volts minus, we know our input is going to be 4640 volts minus. Now if we take the maximum power that this transformer up top, or single phase transformer that we're working with, is rated for, which is 75 kVA, we know this equals to our complex power S, which is the same thing as volt times amps. So we can take this value here, divide it by our voltage on each side, and that's going to find our primary current and our secondary current. So if we want to find IP, we divide 75 kVA by our primary voltage of 480, and we come up with a primary current of 156.25 amps. Likewise, for us to find our secondary current, we divide our rated power of 75 kVA by our secondary voltage of 4160 volts, and we come up with a secondary current of 18.03. Now let's see where these fit on our new transformer. We said that this is our secondary winding N2, and this is our primary winding N1. If this is our primary winding, then this has to be our primary current, IP, which we just found. And then this has to be our secondary current across the winding, which we also just found. Our primary winding current is the same as our input current for our new autotransformer. And our new output current, I2, is going to equal the sum of both our primary current plus our secondary current, which is 156.25 amps, plus 18.03 amps, which gives us a secondary current of 174.28 amps. So the problem is asking us find our volt amp rating. We're going to do this a couple different ways just to check our work and to prove each way works. So our volt amp rating S is equal to our voltage times our current for either our input side or our output side. So let's go on our input side first. Our autotransformer has an input of 4640 volts and 156.25 amps. Let's do the math, and we come up with 725 kVA. Looks good so far. Let's try it on the secondary side. They should be identical. So on the secondary side, we've got an output voltage of 4160 that we're stepping down to from our new autotransformer, and an output current of I2, which we found right here by adding our two input currents to this node, IP and IS, which we found to be 174.28 amps. We check the math in our calculator and we come up with 725 kVA. Okay, looking good. That proves that this formula up here is correct. Let's take it one step further. So before we had a ratio of 1 to 8.67. That's going to be a winding count of 1 on our primary and 8.67 on our secondary winding. Now to find our new autotransformer ratio, our N1 is going to be these two winding counts together. So we're going to have 1 plus 8.67, which gives us 9.67 to our output winding count of 8.67. We can clean this up a bit by dividing 9.67 by 8.67, and we get 1.12 to 1. Now, let's check our input and output currents using our new winding ratio to check our work. So we write down our transformer calculations. We know that V1 over V2 equals N1 over N2 equals I2 over I1. Let's solve for I2 first. We can say that I2 is equal to N1, N2 times I1. We can plug this in as our new N1 we found to be 1.12, our new N2 we found to be 1, times our input amps, which is the same as our IP, which is 156.25 amps. We do the math and we come up with 175 amps, which is roughly the same as we found right here. How about let's try solving for our output voltage of our new autotransformer V2. We should come up with 4160 using our newfound ratio N1 over N2. So we can rewrite this as saying V2 equals V1 times N2 over N1, which is, we know our input voltage is 4640, that's the voltage we're regulating down, times our new secondary winding count, which we simplified as 1, over our new primary winding count, which we simplified as 1.12. We run these numbers and we should come up with 4160. Let's see. So V2 gives us, doing the numbers exactly, we get 4142.86, which is likely a little off in different rounding error, but for the most part, that's going to give us our 4160 value. Next, let's try solving for V1 using just our currents. So V1 is equal to I2 over I1 times V2. So this comes out to I2 is our output autotransformer current that we found to be 174.28 amps, divided by our input current, which was the same as our primary winding current, which we found to be 156.25 amps. We times it by our output voltage on our autotransformer, which is 4160. We should come real close to our input 4640 volts. We run the numbers and we come up with an exact 4640 volts. So all the math checks out. The interesting thing to point out is if we compare our previous power rating of 75 kVA on our single phase transformer to our new configuration, we've got a massive 725 kVA rating. Now you might think, where does that tremendous increase in power rating come from? We're going to be able to step down 4640 volts to 4160, a lot more power, because we're only coming up with a difference of 480 volts from our input to our output, compared to up here, when we're stepping up from 480 to 4160, or stepping down from 4160 to 480, that's a much bigger gap in voltage, so we're not going to be able to transform nearly as much power with that configuration. For more practice, I challenge you to use this same configuration, but instead make it a step-up transformer. Redo the problem and connect your windings. This time, look at it going this way. You'll notice that the direction of all of your currents are going to change. Since you're stepping up now from 4160 to 4640, you're going to have an input current, you're going to have a winding current going down, and a winding current going up. This is going to be your new output current. This is going to be your new input current. And this would be your V2. This would be your V1. And to make it simple, your transformer windings ratio would still be the same. You'll be able to check your work, because when you solve for your power again, you should still come up with 725 kVA. That's because both your currents, your input current will now be equal to your I2 that you found here, and your output current will be equal to your primary winding current, and you're going to end up using the same values, except from before, when this was our V1 I1, this would be our V2 I2, and before, when this was our V2 I2, this should be your V1 I1. Okay, that's it for this video. For more examples and to visit our premium review course, come see us at www.electricalpereview.com.